Okay, so let's have a look at the next couple of questions. Question 5 is all about doing a routing. Again, favourite of functional skills tests. They like you to plot a route out. Because again, that's something you might have to do in real life, trying to find directions, going somewhere, work how long it's going to take you, and so on and so forth. So have a look. I've done a potential route there for you. I've written that down. What you need to do, make your life simpler. Put everything into points of miles, so to speak. So, for example, 1 3/4 is 1.75 miles, 2 1/4 is 2.25, 5 1/2 is 5.5. So, almost think about that for a moment as lots of 25p. 25p in a pound or 100 pence is a quarter. 20.25 is a quarter. 0.50 is a half, 50p if you will. 0.75 is 75p, which is 3/4, and so forth. So that can help you with that particular question. Think of it that way through. You add all those together, gives you 10 miles. Then you're given a conversion to put into kilometres. Say ultimately you want your answer in kilometres. 10 miles divided by 6 miles is your 6.6 kilometres, which is the answer you're actually going to need. So that in its own respect is not such a complicated question as it initially looks. It's just a matter of reading it and plotting it. However, the next question you need to read carefully. Take a step back, because there are 6 surface areas to a cube. 1 on the top, 1 on the bottom, 2 sides and 2 ends. Gives you 6. Because it's very easy to get caught out with an image like that. You think, oh, it's only perhaps 2 sides and a back and the top. You forget the bottom. So remember the bottom part of it. Each part is 2.5 centimetres by 2.5 centimetres. So with it being a cube, that means sides, all sides, bottoms, tops, what have you, are going to be equal. So 2.5 times 2.5 equals 6.25. Then you times that by all the 6 surfaces, which gives you 37.5 centimetres squared. But this is the type of question you need to be very careful of and pay attention to, because it can catch you out. And I think just to say as well, sometimes what you find is, if you notice on question 6 here, in the bit where I put my answer, there's a little 3 in brackets which is slightly greyed out. Use this as your clue, because sometimes that indicates how many steps you might need to put into a question to get the full marks possible. Because remember, you need to show your workings out. By showing your workings out, even if you get the answer wrong at the end, you can get you can still get points. You can put your question answer down, but if you don't show any workings out, potentially you might not get any points because they marked the question wrong because there's no workings out being shown, or you'll not achieve as many marks as you possibly could do. So aim for the best you can and make sure you show your workings out. Next question, we look at this one, find a percentage. I've given you 2 ways of doing that. You could do the old-fashioned way, which is the way I was always taught, 389 divided by 100 times 18 equals £70.02. Or another way you can do it is 389 times 0.18. So always put a 0 and a point in front of whatever the potential percentage is, and that will give you your answer as well. But again, if you've been taught how to work out percentages differently to me and you arrive at the same answer, you carry on using the method you've been taught. Don't let me try and force another method down on you. And then it's a matter of taking the actual money away from the amount you found, and that gives you your answer. So the answer is no, which will be 318.98. We then have an estimation question at the bottom to actually help us work this out potentially if we didn't have a calculator. And what you do is things like that, put it into tens, put it into hundreds, make your life a lot simpler, and then you can work out a little bit quicker and it's a lot easier. And that's something I used to do when I was a retail manager many years ago, is I just wanted to quickly estimate what a price of something would be or a percentage. I'd put everything into nice round whole figures like 10s or 5s, and that would be a lot quicker to do if you didn't have a calculator to hand that gave you the rough estimate. Okay, this is a bit of a nasty question actually. I'll let you read it through, just to recap yourselves, put on pause, have a read, and then just press play and watch you go. Okay. So this is a step question, and this is a question you'll probably want to sit and look at and reflect at quietly without me talking over the top, so make sure you've got your screenshots and your photographs. So first of all, you need to work out the average time, which I've done there, added that all up, divided by the total amount gives me 57 minutes. Now the fridges, sums I've done there, which gives me the basic measurements that I need. We've then worked out that we can't have 0.6 to the fridge. In this case, we're actually going to round down. So we're just going to stick with our 13 fridges. By doing this, come there, 13 times 3, 39 fridges will fit in the new lorry. Now you need to work out the time. And again, classical functional skills question. More about solving a problem than necessarily sometimes you think about maths. So we know it took 57 minutes with 24 fridges to load the old lorry. So that works out 2.375 minutes per fridge. We can do just straight times here. We don't need division on the calculator, it's fine. So that tells us how long it took to do a fridge onto the lorry. So to work on the new lorry, we times that figure by 39, which is fridges in the new lorry, which gives us a new time of 92.625 minutes. If we leave that figure as is, that's fine. So in this case, the answer is going to be no, because it takes 92.925. Sorry, I'm going to correct myself. You notice my deliberate error that I've put in there. 92.625 minutes to load the lorry. Not quite the figure that I've actually put down at the bottom there, which is 92.925. The correct answer is 92.625. So again, just an example of how easy it is to trip yourself up on these questions as you're doing them. And not realising the answers you put down, you're in a hurry, it can happen. So I've actually demonstrated how easy it is to happen, but your correct answer is 92.625. Right, so question 9. What you're trying to find out here is, will the ribbon actually go round the cake? And will it have enough of an overlap? So what you're essentially doing with this particular sum is actually putting essentially, if you can imagine rolling the disc, rolling the cake along. This is like rolling a coin along. You're actually measuring the complete outside of it. Now, to do that, you will need to know pi. They haven't given us pi here. You probably remember that from school, Pythagoras' theorem. What you need to do is just always remember the value of pi as 3.14 or 3.41, or it can be 3.142, but for the purposes of this and the question and for your own revision, unless it's given otherwise, pi is always 3.14 in these tests. So if it's different, they will tell you in the question they want it to be different. Now, all you need to do in this particular case is, if this is 3.14 times 14, and then you have your answer of 43.96 inches, then just add your 6 inches to that, and that gives you your total amount. So the ribbon in fact will be too short. So what we've got to think about here is that actually it's not as complicated as it looks. It's 3.14 times your 14 inches, 43.96, then gives you your final answer there of 49.96. So it's not as complicated as it looks. This, on the other hand, might look a bit more scary. Scatter diagram shows information about 12 athletes who have run a race. Okay, here is the information. Plot this on the scattergram. Okay, so the green arrow I've got going down from age 36 times 29 is you need to find basically those details physically on the thing. So you're plotting where 36 is, and you're then going to plot where 29 minutes is, which I've shown with the red arrows, red cross there. So again, something this question perhaps you need to have a look at. Draw the diagram to the best fit the scattergram. So really what you're trying to do with something like that is you're going to try and go up the centre in this particular instance, which is what I've tried to do. Sometimes difficult, more difficult to draw these on a computer, but essentially the best plot is going to be the line going up the centre. And describe the relation shown in this scattergram diagram. Well, regrettably, it seems to be the older we become, it takes longer to run the race. Charming. Anyway, that's the type of information I want you to try to extract from these type of things. But again, have a look, take a couple of moments again, see what I've done, and you can then see how it all plots and comes together.